In this exercise, we're going to learn how to panel using cross-sections. Simple paneling, using the Panel a Complete Mesh tool, is convenient and easy to do, and we'll demonstrate using this hyperpar that I created earlier in AutoCAD. Simply select the mesh, go to the options under Panel a Complete Mesh, specify the number of panels that you want, we'll use 8 for this example, and then click the tool. However, when we use simple paneling, this panel size is dictated by the program, and it can only make numbers of panels that fit evenly into the mesh. Furthermore, the panel seams are always curved, like the mesh, which can cause difficulties during panel construction. In order to achieve more paneling versatility and control, we panel by making cross-sections. Using cross-sections allows us to customize the size of our panels, and it results in straighter seams. In order to demonstrate how to do this, I'm going to switch over to a copy of our original hyperpar, and as you can see, I've drawn 8 horizontal lines across the mesh, 6 in the middle, and then 2 across the ends. These blue lines show where we want our cross-sections to be, and can of course be drawn differently to get different sized cross-sections. What we'll do is run the cross-section tool, which is going to convert these lines into 3D polylines inserted into the mesh, creating 7 cross-sections. Since we have our 2 lines going across the top and bottom edges of the mesh, as well as the 6 in the middle, then when we go to the cross-section options, we want to be sure and select the option to use mesh edge as cross-section, which will turn the edges of the mesh into cross-sections as well. Before we run the tool, we'll go ahead and make a copy of this mesh with our cut lines, because we'll need to come back to it later. So let's just set that right over here. And then returning to the original mesh, we'll select the mesh and all 8 lines, and then run the cross-section tool. This gives us a series of white cross-section polys that include the mesh edges. If we look at them in 3D, we can see how they follow the shape of the mesh. Now we'll go ahead and delete our original lines, since we don't need those anymore, and we'll do some paneling. InPanel can panel directly from 3D polys using the Panel Between Polylines tool, which is right here. In the paneling options, set this to panel a pair of polylines. Now select a pair of polylines, any 2 will work, and run the tool. This will panel the mesh between the polylines. The resulting panels, however, are going to be a flat approximation to the curved surface of the mesh, and they have straight ends, as you can see here. If we want to change this and give the ends of the panels more curvature that will better reflect the real shape of the mesh, then what we'll do is return to our original mesh with our 8 blue lines, right here, and we'll run the cross-section tool again, but this time we'll do something a little different. First, go to the cross-sections options again, and then add some extra cross-sections. For this example, we'll use 3. Now select the mesh and all 8 lines, and run the tool. This time, we find that in addition to the original white cross-section polys, we have all of these extra gray cross-sections as well. Let's go ahead and delete our old mesh and lines, leaving just the polys. We can panel these as before, or we can select the entire set and panel them all at once using the Panel Between Polylines tool, set to panel color-marked polylines. Now, because we have more cross-sections, the ends of the panels are curved and the panel is shaped to fit through all of the gray cross-sections as well. Of course, whenever you're paneling, be sure to check the shear strength, which can be found in the InPanel text box. With a different set of cut lines, the mesh can be paneled in a different direction. We could, for example, make diagonal cross-sections, as we have here. When we run the cross-section tool on this mesh, we get diagonal polys, which we can then panel using the Panel a Set of Color-Marked Polylines, as we did before. Note that when we do this, a small triangle will probably be left off at the end, but this will not generally pose a problem during panel production. And that's the end of our exercise, and we've learned how paneling with cross-sections can help us to panel with much more control and versatility.